Hello, this is James Parks presenting my second semester computer science project entitled SPORE for the University of West Florida in fall 2016. For this presentation, I'm going to cover an overview of the project, some background, outputs and outcomes. Most importantly, I'll demo the completed product and then give a conclusion. So what is SPORE? So SPORE, the word itself, is German for tracks, like as in an animal tracks. So SPORE is a workflow management system, which basically means that you take a process that's completely manual and then apply, digitize it and apply some automation to it, and the result is a workflow management system. So it resembles the original process, it's just digital in form. Who is it for? SPORE is meant for companies that want to implement a workflow management system but not have to take on some of the burdens of a traditional workflow management system. And I'll mention some of these later in the presentation. But in short, it's meant to be a lean, flexible, adaptable program, which is what makes it unique from your typical workflow management system. So to illustrate my point, imagine you wanted to build some software that somehow built a sandwich, is what it did. So in order for it to do this, you'd have to go to the butcher to get the meat, you'd have to go to a corner store to get for produce, so like tomatoes and lettuce, onions, or whatever else goes on your sandwich. And then you'd have to go to the bakery and get the bread. And then come back home and put all these things together for the actual sandwich. So, not surprisingly, this doesn't seem like the most efficient use of your time as a sandwich builder, going to collect all these things. If you're a sandwich builder, the best use of your time would probably be building sandwiches, not collecting ingredients and transporting ingredients. So, by the same notion, most modern organizations have in some way, shape, or form, digitized a lot of their operations already. They've also, because of concerns and pressures to enter markets quickly, they have been forced to build several heterogeneous operational systems. So most companies don't have like one software solution that handles their entire business from A to Z. More likely they have 5, 6, 7, 20, 30, depending on the size of the organization. They've acquired and accumulated a lot of them over time. Unfortunately, for the individuals working at the company, what that means is that rather than having one place to go to do their work, they have a whole bunch of places to go to. And one of the problems that this presents is that they end up spending a lot of time going to all these systems and figuring out what they have to do, and it's sort of, they're put in this position where it's like a scavenger hunt for them to find what they have to do rather than just focusing on the thing that they're like hired to do in the first place. So think of the sandwich builder. So rather than just building sandwiches, they're going out and getting the meat and getting the tomatoes and lettuce and getting the bread and then coming back and then building the sandwich. So in the same way, people at these organizations with a lot of heterogeneous operational software systems, they end up going to all these systems and collecting all the things they have to do and then actually doing their work. So Spore, the idea is that rather than the user having to do all the collecting, Spore does the collection for them. So Spore goes out to the underlying databases behind the operational software and using SQL queries collects the things that need to be done, transforms them into a common schema, and presents them to the user. So rather than going to 4 or 5 or 30 or however many systems, they can just go to Spore, say get work items, and be presented with the things they have to do. So obviously the idea being they spend a lot less time searching for work and much more time actually doing work. So some of the background for workflow management systems in general. Typically, the flow of implementing a workflow management system is first you do a lot of modeling work. So this is sort of like the analysis part, where you're sort of figuring out, okay, what is a work item exactly for system A, and then what is a work item for system B, system C, etc. Figuring out what are all the attributes about them. The next phase is configuration. So most likely an organization will either build or buy a workflow management system, and it takes quite a bit of configuration. And whether they build or buy, most likely this is going to entail a lot of customization to make either an off-the-shelf version of a workflow management system work for their specific implementation, or it'll take quite a bit of work for their internal development teams to customize it to those same specs. Then, so that's not even the whole thing, so then you get to data maintenance. So most workflow management systems have their own fairly large databases behind them, which means just standing the system up itself, it requires a team of people to do and to maintain over time. So obviously there are different people involved in each of these 3 steps, and you can see how pretty quickly, if you talk about implementing a workflow management system, it gets to be pretty big and pretty expensive. So the beauty of Spore is that these 3 steps basically collapse and result in you basically saying, if I can write a SQL query, then I can implement a workflow management system. So, some outputs and outcomes from the project. We completed, in the first semester, we completed the proposal and the planning phase. So the proposal phase entailed the project definition and the feasibility study. The planning phase entailed the software project management plan, the software requirements specification, software design description, and the software test description. This past semester, we completed the implementation phase, which involved writing the source code. So, I'm going to give you a demo of the finished product. So, just going to execute code. So this is what it looks like. So basically all I did, there's I just executed some code on the other screen, the window popped up, so this is Spore itself. So the basic parts. So there's a menu bar here at the top. You've got your standard Windows minimize, maximize, and close buttons. Then this is the grid where the actual work items are displayed. So the common schema is pretty generic, the column headers. The reason being that they're generic enough to allow you to support a lot of different domains without having to customize schema. So it's basically the assignee, so who is assigned to do this work, the work item type, so what exactly has to be done, or some indication of what type of work has to be done, a date, so to give you some temporal sense of either when it needs to be done or when it became available to be done, an identifier, so some unique identifier to this record, and a link, which is meant to be something that you copy and paste into an operational software system to actually go and do the work. So in the domain that I actually piloted this with during the project was an insurance company. So one of the things that they were going to use this for was processing applications, so electronic insurance applications. So when they got a file in of applications, it would have a territory assigned to it. So we'd grab that as the assignee from the underlying database. The work item type would be application file. The date would be the date that the application file was received. The identifier would be the file name, and the link would be the full file path to the file. So they basically copy and paste this link into a Windows Explorer, take them to that path. They could find that file, open it up, process the applications in it. And then as soon as the file was processed, they marked it in the software system. The software system marked a column in the database as balanced, as in processed. And in the query that actually pulled the work items, in the where clause, they said where it's not balanced. So basically when I've actually done the work, the next time I refresh the grid, it's not there anymore. Anyways, so how it actually works. So first I'm going to grab some work items. So I'm going to click on this menu. I have two options, get work items and administration. So I'm going to say get work items. So it populates the table, gives me a pop-up letting me know, hey, I refreshed the work items. So here are the things, and this is just some dummy data I put into MySQL so I'd have something to pull. And then you can filter here, so if I was person 2 and I wanted to see just my stuff, so I can say I want to filter on the assignee column for person 2. Filters down. So I can also, maybe I only want to work on a specific file, maybe 5 is the file name. So I'll say identifier 5. Filters down. So that's the filtering. I'm going to go to administration. So I guess to give you a preview of what's going on behind the scenes. So what this is actually doing is when I say get work items, it's going and grabbing all the active queries it knows about, retrieving them all, executing them all, and then parsing and formatting the results into the schema, and then updating the table with that data. So administration is where you go to actually add a query. So this is the window that pops up. Similar look and feel, so it has a menu bar and then a display grid. So I've got a menu button, a spot for a connection ID, and then a button that says edit connection. So I'm going to say, well, maybe I'll go through through the schema here first. So connection ID is just a unique ID for that connection. So a connection, I'm calling a connection a query that you want to execute. So the additional data that makes this a connection rather than just a query is information about whether you want this to be active, what type of work item will result in, and a unique ID identifying it. Let's say get connections. So there's a couple I added for this demo, and then obviously I've got some others in here from testing throughout the project. So and you can also add connections, so I'll do that first. Click add connection. You can see it has a unique ID, work item type, and whether it's active or not. So I'm going to say work item type is demo active true. Select demo from demo table. True. There we go. Connection added. And then get connections. And there's the one I just added, the demo. I can also edit connections, so I'll edit the one I just added. So connection ID 14. Popped up a window with the information I just entered. See, I made a typo here. It said form instead of from. Fix that. And maybe I'll say work item types demo 2. Save. Refresh. And now I've got demo 2. So that's basically it. So the idea where the flexibility comes from is this spot here where you're determining in the query itself what the columns returned will be. So it could literally be any domain where you have operational software with a database underlying. You could write a query for and just give the database or give Spore system access to the database and have it pull work items for you. How the query specifically works is in your select statement, you want to have it select these 5 things. So you want the first thing it selects is to be who's going to be assigned to it. So for the insurance company, they had a separate table for the territory. So it was basically based on the folder path the file was in. That's how they would assign a territory. So they just did a select that grabbed the actual work item information from the file processing system. Then it also in the query it interjoined with their assignment table. So yeah, the first column you want is who it's assigned to, then what work item type it is, a date, an identifier, and a link. So it'll always, when it executes the query, it's looking for 5 columns of results. But the query, it is agnostic of how complicated the query is, so long as it's a select statement and so long as it returns 5 columns that are string, string, date, string, string. So yeah, that's about it. So in conclusion, obviously we're 100% complete with the project. There are definitely places to extend the functionality. For example, the original build is for connecting to MySQL databases. The reason I did that is just because MySQL is free and open source. Obviously, a lot of organizations like Microsoft SQL Server or Oracle, so it's built in a way that you could pretty easily just change one of the instance variables, which is the connection information, and just change it to be SQL Server or an Oracle server. Microsoft SQL Server or Oracle server. And it would work essentially the same way. Also, we spent 96% of our budget to build it, so that's good. We came in under budget. So we have a completed working piece of software that's really is useful. The client is pretty excited about it, and we came in on time and under budget. So yeah, and that's about it.